Good morning to everyone. Today, myself M. Subbarao. Today, I want to discuss about the tasks which are performed in the machine learning. First one, what is machine learning? The machine learning is nothing but building a model. By using that model, you can make the predictions. So, to implement any model, we are having three types of learning tasks in the machine learning. The first one is called supervised learning. The second one is unsupervised learning, and the third one is called semi-supervised learning. In supervised learning, what we are doing is we have taken the historical data with the labels, so that by using this historical data, you can train the model by considering some training data. After training that model, you have to test your model performance by giving the test data as a input. That is called supervised learning. In supervised learning, we are performing two major tasks. First one is called classification and the second one is called regression. So in classification, our target variable is always a binary or multi-class label. If you consider any data set as an example, if you take the diabetic data set, the target variable represents whether the patient has diabetic or not. So it contains only two possible values, whether the patient has diabetes or not, yes or no. That type of task will be coming under classification. If you want to predict the share value after some years, then you have to take the historical data of the share price and you have to predict in future. If in such case, that task is called regression. Now come to the second category, that is called unsupervised learning. In unsupervised learning, we have the data but there is no label. So we have to group those data objects into clusters. And the third case, that is called semi-supervised learning. What is semi-supervised learning is, you have the data, historical data, but the size of the data is limited. So what you will do is, with the availability of the small data, you will prepare an initial model. By giving an input to that model, you can generate some random data as a data set. By this data set, you can prepare the models. The type of learning is called semi-supervised learning. So if you take this example, this one is classification and regression. The second one is clustering. So I already mentioned one point. To make the clusters, we need to consider similarity. So to consider the similarity, first you have to calculate the distance between the objects. So to calculate the distance between the objects, we can consider three types of distances. The first one is called Euclidean distance, second one is Manhattan distance, and the third one is Jaccard similarity. These two distances are common measures we are using whenever you are calculating the distance between the points. But the Jaccard similarity is used whenever you have documents, you want to compare the similarity between the documents. How you can implement the Jaccard similarity is, first you will take the number of votes that are common in both document 1 and document 2. After that, this is divided with the total number of votes present in the both documents, so that you can get the similarity of the documents. So these are the three measures we are using. Next one. It is mostly where we can use this machine learning tasks. First one is, if you take any supervised learning or unsupervised learning, while decision making in the industries, we are going to use these supervised learning models. Now come to the semi-supervised learning. If you take the COVID situation, if you want to predict anything, the data set whatever we have in the recent days of COVID, there is no huge amount of data availability. In that scenario, they will go for the semi-supervised learning. Now I will go through the how you can measure the performance of the model after building that. After building any model, you have to measure the performance. To measure the performance, we are considering one matrix. That matrix is called confusion matrix. So I want to discuss about the confusion matrix now. This is the confusion matrix. Actually, if you consider the binary classification, in binary classification there are two categories. First one is positive category and the second one is negative category. if you give any positive category object as an input to the model, our model may predict that object as a positive or negative. So whatever the predictions we have done, which is positive actually and predicted as also positive, they are generally calling it as true positives, and they are the correct predictions. If any object is predicted as negative but actually it is negative, that type of predictions are called false negative. The reason is we are making the prediction as negative but it is wrong. That's why it is called false negative. And the next one is you can give any negative object as an input to the model, but our model may predict the object as negative object or positive object. If the model is predicted negative and really actually it is also negative, they are called true negatives. So these true positives and true negatives are the samples where your model make perfect predictions, and the remaining two predictions whatever we have considered, false positive and false negative, these two predictions are treated as a misclassified things. So by using this confusion matrix you can perform the evaluation of the model. The evaluation of the model means how much accuracy we are generating and how much error the model is generating. Now we have to consider whether we have to use that model or not by considering the accuracy. So let us assume that I considered my accuracy threshold is 80%. If my model accuracy is more than 80, means if it is 85, then this model will be used in the real-time applications. Otherwise this model will be retrained to make better performance. In such a case we will do the confusion matrix to evaluate the models. Next, I am going to some simple example. Let us assume that we have 200 students. Out of 200 students, 150 students are the positive students who got selected in the campus and 50 students are not selected. But by giving that all the students as a input to the model, our model predicted 120 students who are already placed, they got the placement. And for 30 students, our model predicted that they does not have the placement. And the students who have not placed 50, those 50 student samples are given to my model. My model predicted 20 students will be selected to the campus, remaining 30 will not be selected in the campus. So in such a case, if you see this one, these 120 and these 30, these two are the correct predictions. Come to these two predictions, this 20 and this 30, these are the wrong predictions. So out of 200 predictions, 150 predictions are correct and 50 predictions are wrong. So our model accuracy can be categorized by 150 by 200. So the accuracy is 75%. So that if your threshold is considered as 70, then your model can be used. So there are different categories of measures we can use. The above measures are for simplification. I have taken all these questions. First one is the total number of samples. In our scenario, I have taken the total number of samples are 200. Actually, total positive label objects are 150 and the total negative objects are 50 and total predicted positive objects. Actually, our model is making the prediction, total predictions as positive are 140 and total predicted negative objects are 60. Now true positives. The true positive means the objects actually positive and they predicted as a positive. The number is 120. And true negatives, the objects which are actually negative and prediction is also negative. That number is 30. So in general case, the diagonal elements will be treated as true positives and true negatives. And false positives, your model should predict them as a positive, but originally they are negative. That are called false positives. In our case, this 20 is representing the false positives. And the last one, false negatives. So false negative means the originally they are positive but model predicted as negative. Those number is 30. These are the different metrics we are using to build the confusion matrix. So today I want to conclude the topic. So the points whatever I mentioned is the tasks of machine learning. Three types of machine learning tasks we have. First one is supervised learning. second one is unsupervised learning, and the third one is semi-supervised learning. So thank you for everyone.